Next, we are going to see about electrical braking of induction motor. First, let us see about the DC dynamic braking. Okay, this is a diagram for the DC dynamic braking. Here, two stator terminals can be connected by DC supply, and third terminal may be kept open or may be connected directly to other stator terminals. This is called DC dynamic braking. If the third term is kept open, is called two-lead connection, while if it is shorted directly with other stator terminals, called three-lead connections. So when the DC supply is to the stator, the stationary poles N and S, north and south, are produced in the stator. The number of stationary poles P for stator wind is wound. The rotor is rotating. The rotor currents the flux produced by the stationary poles. Thus, the AC voltage gets induced in the rotor. This voltage produces an AC current in the rotor. The motor was the generator, then R losses are dissipated at expense of kinetic energy stored in the rotating part. Next one is regenerative braking. If the rotor speed is increased greater than the synchronous speed with help of external device, it acts as an induction generator. It converts the input mechanical energy which given back to the supply. It delivers the active power to the three-phase line. The phi becomes greater than 90 degree. The power flow reverse, hence the rotor induced EMF and rotor current also reverse. So the rotor produces a torque in opposite direction to achieve the braking. So the electric energy is given back to the line while braking. It is called regenerative braking. The active power delivered back to the proportional to the slip above the synchronous speed. This is the torque slip characteristics of regenerative braking. The main advantage of this braking, while the can be used for useful purpose, while disadvantage of this is fixed frequency supply can be used only for synchronous speed. Dynamic or rheostat braking. In rheostat braking, one supply line RYB is disconnected from the supply depending upon the condition of disconnected line. Two types of rheostat braking can be achieved: two-lead connection and three-lead connection. Two-lead connection means in this method the disconnected line is kept open and is called two-lead connection. Three-lead connection means in this method disconnected line is connected directly to the line of machine. One of the motor terminals is not connected to the supply. The motor continues to run at single phase motor. In this case of breakdown torque, the maximum torque decreases to 40% of original value. The motor develops no starting torque at all. So due to high rotor resistance, the net torque produced becomes negative and braking operation is obtained. In two-lead connection, the braking torque is small, while the three-lead connection, the braking torque is high at high speed. But in three-lead connection, there is possibility of inequality between the contact resistance in connection of two parallel lines. This might reduce the braking torque and even many produce the motor torque again. Hence, in spite of low braking torque, two-lead connection is preferred over three-lead connections. Next one is the torque slip characteristics of motor. In the blocking the reverse of direction of rotation, the motor main principal plucking of motor. In case the induction motor quickly stopped by interchanging any two stator leads. Due to this, the direction of rotating magnetic field gets reversed suddenly. This produces a torque in the reverse direction and the motor tries to rotate in opposite directions. So effectively the brakes applied to the motor. Thank you.